The next one is 3D printing, which is very interesting in logistics in general, but I think there can be lots of interesting application in transportation and in port systems as well. So 3D printing technology is set to be one of the next technological revolutions with the greatest effect on productions and sale flows. So here I've added a few pictures. As you can see, the application, what can be printed via 3D printing, it's really wide. Even human organs are today printed via 3D. There is application in real estate, in medical applications, even food, it can be 3D printed. There is quite a few video you can find on the internet of hamburgers and pizza which are 3D printed. So what is it in general? 3D printing is considered a type of additive manufacturing that prints. So why is known as additive manufacturing? Because it adds layers. So it adds materials over material to manufacture a specific product. What does it print? Well, it prints a three-dimensional objects by adding layers of a specific material. So normally the material is plastic, metal, alloys, or ceramic, but even is salt or sugar. Even candies now today are 3D printed. Why is it different from traditional manufacturing? Well, 3D printing adds layers, whilst traditional manufacturing usually subtract layers. So it cut layers from a print. Right, here I've got some responses to a survey of over 300 professionals responsible for 3D printing at manufacturing companies. And here they were asked in 2019, what are the most common industry for each 3D printing applications? So as you can see, the respondent indicated that medical devices and research and development as a major area is one of the major areas for 3D printing today. Medical devices, so instruments, prototypes, and so on. Another important one is given by production parts and for consumer electronics. So this is, of course, is a very important and very high value industry. 39% indicated automotive and, for example, also bridge production. And 38% indicated transportation. This is mostly interesting to us, and particularly it's interesting for repair and maintenance. So there is quite a few of pilot projects which indicate how, for example, 3D printing can be useful on board ships. So imagine there is a ship en route in the middle of the Pacific Oceans, and suddenly there is a problem with the engine, and a spare part is needed. So the spare parts might not be stored in the engine room of the ship, but rather might be printed. So with the digital twin, we have a copy of what the spare part looked like in a cloud, and the ship itself, so the chief engineer or whoever on the ship might be printing live in real time that specific spare parts to be used in the engine. So the applications are quite interesting, in my opinion, for transportation. And last but not least, 3D printing, there is quite a few applications as well in medical devices. So different ones, okay, jigs, tooling and fixtures as well. So a bit different with the first one. The first one was more about R&D. This one is more about the physical tooling and the fixtures. So a few examples of printable items on 3D. As we were saying, the market is still small, but the potential is quite huge. So these are actually a few examples of items that were printed on 3D printers. For example, shoes. Shoes is something that has been printed quite a few times by now. Clothing as well. Even buildings. Chinese have built a whole building, and that building has been 3D printed. That was a huge project. But also miniatures. Okay, so those very niche markets for e-gamers and so on are interesting outputs for 3D printing. And even food, candies, pizzas, burgers, even steaks have been 3D printed with specific vegetable materials. So what are the advantages of 3D printing? Let's see just a few. No waste. As we were saying, 3D printing is adding layers over one another. Therefore, it's quite from a waste perspective, it's quite interesting. Usually, 3D printing use material that are light and stable. So this more has got to do with what materials are used. A big one is that, of course, products can be customized. So by digitizing a picture or a product that is digitally stored, then by computer software, that product can be modified. And that's the very interesting part. Imagine a building, as we were saying earlier, that need to be 3D printed. If we want to change the specification of that building, or really a smaller product, a miniature, whatever, we can digitally change it and then make to order. So whenever that product is ordered, we can manufacture and produce it. We don't need to produce it in advance. Of course, it's adaptable in the sense that products, once again, can be modified and can be adapted to very quickly for manufacturing purposes. The other one is the point of sale production. So 3D printing enables decentralized production overall logistics expenses. So a very important advantage is that 3D printing can be pretty much produced anywhere. So anywhere with a 3D printer at home or in the office can manufacture product. We do not need to have a centralized production system in a factory or in a manufacturing point. The advantage is that probably 3D printing products might have quite an important market application in niche products. So of course 3D printing is not going to entirely replace traditional manufacturing, but 3D printing might be quite interesting for niche products such as, for example, miniatures and so on. There is also some elements that in relation to the environment about CO2 emission reduction, as the material used are more customer friendly, and the production is decentralized, so everyone use less energy, and then that can be quite competitive. So in terms of price, this is a market that can have a future in relation to price competitiveness. However, there is some limitation and challenges that go with 3D printing. Of course, the major one is that there is no mass production, so there is no scale economy. We can't decrease the cost of unit by adding one more unit. So, of course, that is why we were saying that 3D printing should focus on niche markets rather than mass production. Some materials are still not perfect, so some materials use some materials used in the process of 3D printing that got a rough surface. So from a quality perspective, the materials that are used still need to be improved. Of course, there is less security. If we think, for example, like everyone if everyone would be producing a specific product in their home, then there might be a security issue with regard to the quality of the product. With regard, for example, if we produce toys, then what if is it safe for children to play with it? Even with regard to security, there was an interesting project that was actually carried out by a journalist, and the journalist produced a gun via 3D printing, and he carried that gun. It was produced in, I think, in plastic material. So anyway, a material that was not detected by a metal detector. And he attended a seminar where there was an important politician that was giving a speech. So there is a lot of issues with regard to security if anyone has the freedom to produce a product in their home, of course. Then there is liability issue. So if you sell a specific product that is 3D printed, what if the product isn't safe? What if the product is damaged? What if the product, there's been examples of toys that were literally exploding. So who's going to pay for that? There is still a lot of gray area when it comes to the legislation and the regulation in place with 3D printing. And of course, there is intellectual property issues. So if you can manufacture yourself, if you can print yourself Nike shoes, then of course there is intellectual and property issues in relation to the copyright, in relation to the licensing with the trademark, and so on. So this is also one area that need to be addressed in relation to 3D printing. So in relation to 3D printing, connecting this issue with transportation and the port sector as well. For sure, 3D printing might have an impact on current procedures, transportation, and lead to a sort of deglobalization. A recent survey carried out by PricewaterhouseCoopers, PwC, which is a leading consulting organization, found out that 41% of air cargo business and 37% of ocean cargo business could be at risk due to 3D printing. So this is quite an estimate. In terms of numbers are quite big. Of course, this does not mean this is going to be the case, but that makes think on what could be the impact of 3D printing and the process of deglobalization. What if production start coming back to closer to the consumption center? For example, from China, from the Far East back to Europe, for example. Not on all products, but for some specific products. So that should make us think on what are the implications here. And in terms of implications, and particularly for ocean cargo, as ports are involved and maritime transportation is involved, I have some really open question here. So if 3D printing is happening on a larger scale, and that is true that 37% of ocean cargo is at risk, then could we see lower volumes of containerized goods? In other words, could we see lower volumes, lower numbers of containers shipped from the Far East to Europe, for example? On the other hand, could there be more raw material exchanged? So as manufacturing would be taking place closer to production center, maybe could we see more raw material imports in Europe and in US or not? Then another one, so for example, if we see lower volumes of container exchanged, could ships on average get smaller on specific shipping routes or not? That could be the case for some specific market at least, if this number is correct. And could we see more regional shipping? So could we see more, for example, shipping taking place within Europe or within US rather than a truly worldwide shipping? That also could be the case if more production is concentrated in some specific markets. So of course, there is no right-wrong answer here for this question, but these are really some open questions for all of you to think about when we think about 3D printing implications. So I found that Port of Rotterdam actually, and Port of Rotterdam is always coming back in relation to new technologies implementation, has launched a project called RAM Lab in the port. So the port strategy is to become a center of 3D printing actually for sea transport and the offshore industry. So as we were saying, for the circular economy, even 3D printing could be one of these technologies that used within ports for creating new business opportunities, for creating new markets. The Port of Rotterdam specifically is aiming to 3D print spare parts for ships and for the offshore industry. So in November 2016, RAM Lab, which stands for Rotterdam Additive Manufacturing Lab, was opened. And RAM Lab is the first 3D metal printing laboratory in the maritime sector. So as far as I'm concerned, that's the only port worldwide which has started such a project. And RAM Lab has manufactured the first 3D printed ship propeller in the world. So as we were saying with 3D printing, more generally for products, but how about for maritime spare parts and maritime parts actually? So could we see an increase of ports taking this opportunity and becoming 3D printed center for specific products or not? This is something that nevertheless is starting. Another example is the Port of Barcelona, but it's a bit different. It's not, in this case, the Port of Barcelona is more as acting as an innovation ecosystem incubator rather than 3D printing specific maritime spare parts. Nevertheless, the first 3D printing technology incubator in Catalonia is located in Barcelona, Zona Franca, which means free port zone, a research hub in collaboration with the most powerful companies in the sector and emerging enterprises. So in this case, although it's not strictly related to maritime products and maritime spare parts, but rather this is a more general 3D printing in cooperation with other companies and other organizations. I've got one more video to show you, which is about 3D printing, and the source is Arabian Business. And it's interesting to see how even Middle East ports, particularly Dubai and Abu Dhabi, are thinking on how can the port adapt and sort of develop a 3D printing market. So I hope you also enjoy this video about 3D printing in the Middle East port.
you already have the infrastructure. The UAE has a very ease of business environment, has a fantastic infrastructure to re-export, has the platform to offer that. It's just a matter of moving it, and we're talking about not a business in millions or tens of millions. We're talking about a business in creating a market opportunity in the billions of dollars. Dubai today is the largest re-export hub and warehousing, offers the largest warehousing region that you have. Most of the multinational companies use Dubai as their hub to re-export. If you look at the technology of additive manufacturing and allowing manufacturing to be localized to an extent, but Dubai is in a prime position to place itself and to position itself as being the hub for these MNCs and for large regional and international companies to use it as their manufacturing hub, or what they call direct manufacturing. You start replacing physical inventory with digital inventory. And instead of shipping physical inventory, you actually ship the digital files and manufacture it locally. So you can see a massive transformation where instead of warehouses, we actually have digital factories where you send a file, you manufacture it.
Okay, and extending the discussion about 3D printing, in ports, I would like to look at it from a perspective of supply chain and logistics more in general. So the first trend that might occur, okay, again, this is not right wrong, this is more a prediction of what could be happening. And the first one is 3D printing will offer opportunities for mass customization and decentralized production. So 3D printing promotes local and regional production, and that the next 20 years will see 3D print centers spring up close to sale markets. So this is what we're saying. One of the implications, one of the trends that might be happening is that 3D printing centers coming closer to sale centers, so consumption centers. And so we could see something that in logistics is known as nearshoring. 3D printing gives them the option of nearshoring their production back to high-wage countries. So as 3D printing can be customized and can be done quite cheaply, it doesn't make sense to keep production in low labor countries, rather bring it back to consumption center. And the third one is we could see made to order. So manufacturer will no longer keep large volumes of standardized products in stock, moving instead to more flexible manufacturing models based on the made to order principle. So all the warehousing and inventory management system as it's known today, we do not keep any more stocks in warehouses. Rather, we shift. There is a paradigm shift. It's a very important shift. So made to order. We only manufacture when a customer make an order. The second one is last mile shipping will increase. So if goods are printed close to consumer, then as we're saying, shipping routes might shift. And if shipping routes are likely to shift and go back to the consumption center, then we might see an increase in last mile shipping. So more investment in logistics and imports as well might be needed from the distribution center to the final consumer. The third trend is that the market for 3D desktop printers will continue to grow. So when it comes to 3D desktop printers, the issue is how make easy to make design. So the first one is download the picture from the internet or your own and store it digitally. Then a 3D object prepared in a STL file format. And the third one is 3D printer, read the file and print it. So pretty much we need a digital copy or simply a picture of a product that is then printed. So it's quite easy. What is interesting is that the world's first 3D print shop opened in Zurich in Switzerland in 2012. An additional print shop opened in Munich in Germany and Vienna in Austria in 2014. So really the consumer, if you want a 3D printed object, you simply need to email a picture and then a 3D print object can be printed. Customer can go to have their own custom design object manufactured. So this is also a trend that might continue to be seen in other countries and other cities. The fourth trend is replacement parts will be stored in virtual warehouses and printed on demand. So remember what we were saying earlier about the digital twins and virtual storage. Well, that links very well the concept of 3D printing. So 3D printing will make easier producing replacement parts, as the example of manufacturing a spare parts with a 3D printer on board a ship or on board an airplane. So replacement parts can be digitally adapted and printed out only when needed. So the military usually is at the forefront of using some technologies. For example, the British, the American, and Chinese militaries have already adapted 3D printing for these very reasons. So militaries around the world are already using 3D printing and apply the concept of make to order. So whenever it's needed, we produce it. We don't keep big inventories in stock. So the US Army, for example, print out surgical instruments and protective masks directly in war zones. And this is really to reduce, once again, the stock that you're carrying, which might be difficult and might slow down operations. And that's also expensive. So for businesses overall, it's expensive to carry on inventory. Therefore, there is some niche application which are interesting for 3D printing. The fifth trend is custom authorities will lose their oversight role or might lose their oversight role. Well, maybe this might be an exaggeration, but there is some food for thought on that as well. So when there is no longer any physical border crossing, so when we do not have anymore a product coming from the Far East and being imported in Europe, and there is a border that need to be passed, there is a border control with custom authorities that need to be passed. There is also no longer a role for custom authorities. So the custom authorities might be harder for custom authorities to sort of monitor the flow of products within specific regions if there is no border crossed. So if goods no longer pass through border controls, then custom office no longer have access to them. The custom authorities ensure compliance with consumer protection measures and export control regulations, which provide security in international commerce. So for the last topic that is covered is a broader topic, and that's more about the future of work in light of smart technologies. So I will try to address some questions. So what's going to happen to workers in the transportation sectors if some of this technology will be implemented? So that's I believe, quite important to be discussed. So the first question, which new and emerging technologies will be introduced in global transport? Okay, of course, we have seen many of them. This does not mean that all of them will be implemented in all ports worldwide. We know that each port is different. Each port has a different vision, and each port particularly has a different capability, financial capability, operational capability. So not every port will implement the same technologies or will not implement any technologies at the same time. So across industries, a number of trends have been evolving around digitalization, increased level of interconnectivity in production processes, and advanced level of automation, so as we have seen previously. The implementation of these technologies has already started in many segments of the transport chains and will continue to have effects on all transport modes in the future. So we are moving a bit away from the port area to look more broadly different transport mode, including shipping. So I've taken this information from a study carried by the World Maritime University called Transport 2040, Automation, Technology, Employment, the Future of Work. And the author of the study identified 4 major clusters of novel technologies. Number 1 is automation of vehicles and infrastructures. So we talk a bit about automation, particularly in the port area with yard equipment and crane, automated crane and so on. But automation might extend further. So there is a lot of pilot projects carried by several countries, including Korea, about autonomous shipping. So shipping might become autonomous at 4 different levels, at 4 different degrees, but as well as trucks, for example, and airplanes might enjoy certain levels of automation. The second one is maintenance of vehicle and infrastructure. We have talked about that a little bit in regard to predictive maintenance of equipment in ports with artificial intelligence and with IoT applications. Number 3, user interfaces for customers and equipment operators. And number 4, new services, so new business model. Mobility as a service, for example, and a really new business model for transport on demand. So one of the results that these studies show is that the introduction of automation, for example, will be evolutionary rather than revolutionary. In maritime transport, the adoption of novel technology is lower. We know that the maritime industry is a very traditional, very close-minded industry. They don't like outsiders, they don't like new technologies. So compared to other sectors, for example, warehousing, for example, other businesses as well, the port and maritime industry are adapting this technology much slower. So regulation regarding autonomous transport are unlikely to be achieved within the next decade. So there is a lot of gray area in regard to the regulatory framework for autonomous transportation. So if there is a strong economic benefit expected and social acceptance exists, so if people do accept the adoption of these new technologies, highly automated transport solution could be implemented at regional level and governed by national legislation. So if the economic output might be positive, and if the society accepts such a technology, we could see autonomous transportation and in general automation at the regional level. So beyond long-term economic benefits, automation is triggered by demography, safety, and efficiency. So we need to sort of include these elements in order to see the long-term benefits advantages for automation. Technology and automation are often triggered by the safety and efficiency concern of operation and not always motivated by reducing labor cost. So in some cases might be, of course, to reduce the health of the personnel or reducing accidents at workplace, rather than saying, okay, I implement automation because it's cheaper. More automation has been introduced to the European rail industry to outweigh the consequences of a labor market mismatch due to aging population, while maintaining a high level of safety. So in some regions, namely Europe for example, where there is a quickly aging population, automation is needed to replace labor actually. In many areas, automation is likely to result in a shift of the workforce, not in a labor reduction. So as we were saying, many of these technologies will result, of course, in job loss, but also they will result in a creation of new jobs and new job opportunities overall. As an example, in transportation, the highest potential for automation is in low-skilled jobs. So there is a high risk of impact from automation. So those that are low-skilled professionals might risk a higher impact from automation. At the same time, however, the further introduction of automation will create a demand for new type of jobs, such as remote operators, worldwide operating maintenance crew. So there will be a lot of opportunities coming from software engineers, remote operators, and so on. As a result, the demand for labor will not completely disappear, but the requirement and skills needed for individual jobs will change. And as I was saying in the first session, it's very important that ports which are aiming to become smart ports and implement new technologies, to sort of have a vision on how to process this shift in labor. They need to promote education and training initiatives and sort of retrain people that might need to shift jobs in the upcoming years. So if we look at the transportation volume up to 2040, I know that that's quite a difficult exercise to make such a long forecasting, but overall the transport volume is expected to increase, but at a decreasing rate. So if we look, for example, at this figure, we can appreciate the fact that seaborne, which is the top area with the light blue color, is certainly increasing, but is increasing slower than in the past. We can see that road transport, which is represented by very darkish blue color, it's also increasing, and rail is almost stable and pretty much like air freight is also set to expand a bit, but it's as you can see is almost non-visible from this figure. So seaborne trade and road transport enjoy a relatively high growth rate, but the growth rate itself is decreasing. It is forecasted that overall trade, measured per ton mile, so per ton of cargo transported per mile carried, will experience a 2.2% annual growth over 2015-2030 period, and a 0.6% annual growth rate period after 2030. So this is important to say, what are the implications for shipping, what are the implications for ports, and eventually what are the implications for the implementation of smart technologies. So another interesting aspect is the improved productivity expected from technology advancement might lead to model shift at a regional level. And this is a case study with regard to the European Union. So as you can see on the left side, you have the case of cargo transported by different mode of transports in 2015. As you can see, road transport is over 50%, and rail transport is around 12.30%, and inland waterway is around 4.3%. It is expected that there will be a very important shift on the mode of transport for cargo. If you look at 2040, for example, we can see that road as a mode of transport might decrease its overall market share with about 38%. And we can see that, more importantly, rail transport will increase, so from 12.3 to 15.6%, so more cargo will be carried by rail. But even more importantly, there is a much wider use of inland waterways. So from less than 5% to almost 15%, 14.4%. And maritime transport is almost stable. There is not a great shift with regard to maritime transport. But taking the very same example, but considering Asian countries, as you can see, Asian countries, road transport is literally dominating the cargo transport. So in 2015, 91% of cargo moved by road. If we look at rail, only 1%, and inland waterway, only less than 1%, almost 0.08%. And that's a major shift in 2040. In 2040, road transport will decrease, reaching 53.5%. And the big winners are going to be rail, which from 1% will jump to 20%, and inland waterway. Inland waterway from an insignificant percentage to almost 5.6%. This is very important to consider other mode of transport and of course to reduce congestion in ports and reduce emissions as well. So transport has a high potential for automation like other industry, but as we were saying, that comes at lower adoption rates. And here this figure is employment weighted probability of automation. So what is the probability that these jobs will be automated? Of course, the first idea is that low skill and medium skill labor are more prone to automation, as you can see. And in the transport sector, the adoption rate is lower than the whole economy. So as you can see, high skills labor are less prone to automation, are less at risk of being automated. And this is one figure that show the automation technology, how the automation technology have the potential to reduce global demand for transport worker in different countries. These countries are Denmark, France, Japan, Korea, Norway, and Sweden. And they've been divided according to low skill, medium skill, and high skill labor. Once again, the picture is indicating that high skill labor are less prone to being substituted by automation. And on the other hand, low skill and middle skill are more prone. What is interesting is that Korea, for the medium skill, has a much lower percentage compared to others of being at risk of automation. And we know Korea is the #1 country worldwide with regard to the use of robotics and automation in business. And this is the impact of automation on the transport labor force, which is varying across skills and tasks. So on the horizontal axis, we have the current automation. So what is the current level of automation for different jobs? For example, docking pilots, low automation, and our aircraft pilots already has got quite a degree of automation. We know that in flight, the captain can can put on the autopilot. And on the vertical axis, there is the potential of automation. So what is the probability that this specific profession or segment will be automated? So if we look at jobs that are highly at risk of being automated, we have crane operators. We know that. Automation has come to ports already. We have, for example, cargo agent, lift truck operators, electronic technicians, railroad contractor, heavy truck drivers. So those are a few professions found in the shipping and port industry which are at very high risk of automation. On the other hand, docking pilot, ship officer, for example, ship captains are still professions that are seen as at low risk of automation. Automation will be developed and implemented at different rates in different regions. So here we have a world map, and you can see some countries have been highlighted, and there is some numbers for each country. For example, if we look at China, China is in green. China is in green, which says that generally 6.5 and maritime 6.8 means that China is quite prepared for automation. For example, if we look at, sorry, that was the number of Korea. China generally is 5.6 and maritime 7.9. So China is very well prepared for automation coming in shipping and maritime. For example, if we look at Northern Europe, if we look at Denmark, or we look at Norway, or we look at Sweden, these are all countries that are quite well prepared for automation in the maritime sector. On the other hand, there is other developing country. If you look at South America, if you look at West Africa, for example, Nigeria has got the lowest preparedness for automation in the maritime, scoring 3. So this is to say that we will see automation being implemented in countries in different pace. So to conclude this presentation, there is a readiness gap among developed and developing countries in the maritime sector. Some countries are time to become leaders in the field of automation and technology in the maritime sector, and their maximum efforts are focused on building the requisite foundation. Requisite foundation means putting up operations, legislation, economic benefits. Other countries will not rapidly introduce the emerging new technology because their priorities are developmental or focused on meeting the basic needs of their population: food, healthcare, and education. So this is to say we're going to have a technological divide between developed and developing countries. Many countries have not developed yet long-term plans for automation in the maritime sector. So there is yet, even though there is a pilot test and projects with regard to automation, there is not yet long-term strategies for automation. While some countries are seeking to become leaders in a number of domains, in the development of relevant regulation, infrastructure, and competences, these countries are still at an early stage of setting up policies and strategies in response to anticipated developments in the industry. So this is the end of my presentation. I gave you an overview of smart ports in theory and in practice. I hope you enjoyed this lecture. I hope you have appreciated some of the insight or the practical application that we are seeing with these new technologies. And please feel free to contact me if you have any doubts or any comments. And later on, I will probably give you some simple questions to answer if you like in preparation of your country report and action plan. So thank you very much for your attention, and hope to see you soon.